So we get the direction Q, and once we get this direction two ways, we know the find the line PQ. So let it meet to two plus 4 I say cross multiplication. So I write one after the other. So I write 29 R1 in R2, this is R2, and plus 8 equal to 0. And then cross multiplication R1 minus 8. So minus 8 and 21 into 29, 21 into 8 over into minus 21 left with plus 8 times 9, 23, 7 minus 168 and 1 over negative 441 and plus, so that gives me 19, and so you will get 522. Now it simplifies a bit. So R1 over you get negative 81 is R2 over negative 81, and this is 1 over 81. So it means you are just getting R1 over 1, R2 over 1 is 1 and negative 1. Often they will simplify in exam problems. Calculate, want to check your concepts. So R1 is negative 1, R2 is minus 1. So let's review that what we got till now. Given we wanted to find a line L that intersects both lines L1 and L2 at right angles. So we started with a general point P on L1 and Q on L2. So these PQ are there. And we say that so this line L, I can easily write. And so now the line L with this dr, that is the big one, negative 4, 1 plus 4 to minus, perpendicular to the line L 4, 3, having direction is with the negative 4, 1 and 1. So I just apply the condition that cos of theta is L1 L2 plus M1 M2, and we end up with this both side equals 0. And after simplifying, we are getting two equations in R1 and R2. We can solve for them. We got our answers. R1 is -1, R2 is -1. It means now we got points. So the point P, if I put the point P, look at these numbers. The point P was -4 1 plus 4 out. R1 and R1 is -1. So I'll get R1 is -1 here, and -1, I'll get -2 here. And if I put R2 is -1, R2 is -1 as we have got. So we'll get here 2, and then we will get here 1. So 2, 1, 2, -1, and then 6. So we got these points P and Q. So our point P is 1, 3, and -2, and our point Q happens to be 2, -1, 6. So now we know that these are the two lines, and we have found a line which is perpendicular to both of them. That's PQ. Know that this line meets these lines L1 and L2 at P and Q. So we got this line PQ. So this PQ will be 1 square and plus 4 square and plus 8 square. And that would, of course, give you 1 plus 16 and plus 64. So you're getting just 81. And so that answer is 9. If someone asks to get ITs exactly asked this kind of problem in 2017 and before also. In 2010 also. So PQ is 9. Now, PQ, then that is obvious now. In symmetric form, that the line passes through 1, so x minus 1, y minus 3, and g plus 2. And over direction ratios, those numbers in any order. We just have this 1, 4, and 8. So we get 1 here, and then we get 4 here, and 1 we get, and then -4 we get, and then we get 8. So 1, -4, 8, they are the direction ratios. Two comments about this. What actually we have done is that the shortest distance between these two lines without telling you so. Let's get deeper into it. So the lines were given that if I write the line again like this, that you have been given lines on the line, that was your -3 and 6 and 0, that was 1. And then direction ratios were -4, 3, and 2, that was for L1. And for L2 line, that point was -2, 0, and 7, and the direction ratios were -4, 1, and 1. We can just check to be sure. So and we are good. We have got these points of L1 and L2, and we got PQ. And somebody asks you that find sense between. Of course, in exam we did not check, but for our benefit we can check here that whether these lines given. So it means that we already have two directions. This one, -4, 3, 2. One direction is this one. We can find a third direction, that is so any this point was suppose A and this is B, then direction ratios of AB, that is you can subtract in any order, and so I just choose this order. So -3 and this 6, and then -7. I can choose like this, and then I can form the determinant. So we have got three directions: direction AB and L2. We know that if I form the determinant corresponding to these, means I write here -4, 3, and 2, -4, 1, and 1, L1, L2, and I write AB, that is -1, 6, and -7. we can check quickly that this is not 0. In fact, it is left for you to verify. So this will be not 0. Once they are non-zero, we know that these lines are not coplanar, and so they are skew lines, non-coplanar, because they're anyway not parallel, because these two ratios. So these two are skew lines, and so somebody could ask you that find the shortest distance. So if suppose I ask you find the shortest distance between these two lines, for that there is no need, I repeat, for that there is no need to find points P and Q themselves that we found. That was a long way. But if somebody asks you that find the points also, then there is no way, you have to find. So now, if that is the case, then what I can do is that I will find PQ directly like this. Use a formula projection. It's like this, that if you have got point x1, y1, g1, and x2, y2, g2, and these are the 2 points, say any point x and y, and then we want to find projection on the line which a, b, and c are direction ratios, drs, then my answer is a times x2 minus x1 plus b times y2 plus c times g2 minus g1. So c times g2 minus g1, and over square root of a square plus b square plus c square. So that happens to be the projection of segment xy on the line L having direction ratios a, b, and c. Let's apply this. So let's apply this. Let me change the color maybe. And so we want here that we want the shortest between these 2 points. So let the shortest distance, or I can do here only the diagram. Let the shortest distance meet at some line, some point. So let's call it PQ. They are the same PQ, of course, but we don't know right now. So this is some PQ they meet. So I will be done if I can say that I can find DRs of PQ, and then I can take projection of AB along PQ. So I will have to make another diagram maybe, because this is too crowded. So this is here. So let's copy the diagram quickly. So this is points, and so you are given this kind of thing, that this is -4 and 3 and 2. That was the direction ratio. This point to -3, 6, and 0. And the other point here was -2, 0, and 7. And this was -4, 1, and 1. So we are saying this is the direction. This is the direction of the line L1 and L2. So I'm saying, okay, let there be some points P and Q. I need not find P and Q, I repeat. I just want to find PQ. My interest is finding PQ. That is the shortest distance between L1 and L2. So already we know the points. So let's name the points A and B. So I want to find projection of AB on the line PQ. We know by definition that PQ is 1 and 1. So let's check these ratios that we are getting this kind of thing. And then we have to just make a cross product, so that we can do easily. That is 3. First term will be 3 minus 2. That is 3 minus 2. That will be your 1. And then next will be -8 and plus